Let's talk about the signs of trig functions. Okay, now, theta, if theta is not a quadrantal angle, which is what we talked about in the last video, what they were, then the sign of the trig function actually depends on the quadrant in which theta lies. Again, remember, r is always positive. R is always positive. Let's go back and remember our quadrants. Our quadrants 1, 2, 3, and 4. Now, if we go back and we think about, all right, let's talk about the Cartesian coordinate system. These are positive x's. These are positive y's, which means that the ordered pair in this quadrant 1 is positive x and positive y. These here are negative x's. These are positive y's. So in this quadrant, quadrant 2, I have negative x's and positive y's. In the next column, or quadrant, sorry, I have negative y's down here and negative x's up here. So that in this quadrant, quadrant 3, negative x, negative y. The last quadrant, quadrant 4, I have positive x's and negative y's. So I have positive x's and negative y's. So that's why over here I've written these using this notation. So again, quadrant 1, positive x, positive y. Quadrant 2, negative, positive, and so forth. So if we think about a point in quadrant 2, negative, positive, the only trig functions that are positive in that would be sine and cosecant. All others are negative. Now let's talk about that. If I want to talk about quadrant 2 points, quadrant 2 points are negative, positive. And if I want to talk about my trig functions, let's talk about this. Sine, quadrant 2 angle, y positive, r always positive, which is positive. Cosine, x negative, r always positive, which means negative. Y positive, x negative, which will give you negative. Cosecant, r, which is a distance, always positive. Y positive, which will give you positive. Secant, r positive, x negative, which will give you negative. R positive, x negative, which will give you negative. So let's look at this. For quadrant 2, only sine and cosecant are positive. Everything else is negative. And you can go and you can prove this. And I want you to do that. I want you to go and I want you to do this for quadrant 1, for quadrant 3, and for quadrant 4. And I want you to find out, well, I'm going to tell you, but I want you to prove what we just did for quadrant 2 using each and every one of these quadrants. And what you're going to find is this. You will find that in quadrant 1, all trig functions are positive in quadrant 1. In quadrant 2, you will find what we just found, that sine and cosecant are positive in quadrant 2. Okay? For quadrant 3, you will find that tangent and cotangent are positive in quadrant 3. In quadrant 4, you will find that cosine and secant are positive in quadrant 4. Excuse me. One way to remember this. All starts with an A, Sine starts with an S. Tangent starts with a T. Cosine starts with a C. So all smart trig class. All functions are positive in quadrant 1. Sine and its reciprocal are positive in quadrant 2. Tangent and its reciprocal are positive in quadrant 3. Cosine and its reciprocal are positive in quadrant 4. So let's talk about how to use this. So, for example, first, if tangent less than 0 means negative. Cosine greater than 0 means positive. Name which quadrant theta lies in. So what it's saying is, where are both of these true? Well, where is tangent negative? Tangent is negative where? It's positive here, and it's positive here, which means it must be negative in Q2 and Q4. Cosine theta positive. Where is cosine theta positive? Quadrant 1 and quadrant 4. So where would theta lie if both of these things were true? Well, what quadrant shows up in both? So that when tangent theta less than 0 and cosine theta greater than 0, then theta lies in quadrant 4. So theta lies in quadrant 4. Do another one. Sine is less than 0, which means negative. Cosine theta less than 0, which means negative. Sine is negative in 3 and 4. Cosine is negative in 2 and 3. What quadrant shows up in both? That means that when sine of theta is less than 0 and cosine of theta is less than 0, then theta lies in quadrant 3. Alright. Let's look next at finding some values here. So first of all, it says find cosine and cosecant given the following information. Tangent theta is of negative 2/3. This is negative. And cosine greater than 0. That's positive. Alright, first of all, tangent of theta is less than 0. Where? Tangent of theta is less than 0, meaning negative, in quadrant 2 and quadrant 4. Cosine is greater than 0, meaning positive, in 1 and 4. The quadrant that shows up in both is quadrant 4. So theta lies in quadrant 4. Quadrant 4, what kind of points does quadrant 4 have? In quadrant 4, it has positive x's and negative y's. So that when you have tangent of theta is y over x, remember, just because a number is written like this does not imply that the negative goes with the top. It could also, it means the same thing as this, whereas the negative's in the bottom. So the one thing you have to do is figure out, okay, what kind of point am I talking about, so that I know what quadrant I'm in, so that I know where that negative really goes. In this case, the negative goes with y. So that this says tangent of theta is negative 2 over 3. It says that y is negative 2 and x is 3. Well, if I have y and I have x, I need to find r. R is the square root of x squared plus y squared. That's going to be the square root of 3 squared plus negative 2 squared. That will give you the square root of 13. So r is the square root of 13. So I want to find cosine theta, and I want to find cosecant theta. Now cosine is x over r, and cosecant is r over y. Cosine's x over r, x is 3, r is the square root of 13. You have to rationalize, so you get 3 square roots of 13 over 13. Cosecant's r over y, so you have the square root of 13 over a negative 2, and negatives always get moved up. So you have negative square root of 13 over 2. Let's do one more. Here again, we have, for example, this time, tangent of theta is 3/5. This means positive, or it has a positive number. Cosine less than 0, negative. Again, find cosine and cosecant. First things first. Tangent of theta is greater than 0 or positive. Where? Tangent of 0 is positive, or tangent greater than 0 is positive. 1 and 3. Cosine theta less than 0, which means negative. Where is cosine? Negative. 2 and 3. Where do these quadrants line up? Which shows up in both? Quadrant 3, which means theta lies in quadrant 3. Quadrant 3 has what type of points? Negative x and negative y. Okay. So that means take my tangent of theta is 3 over 5. What did I just say? Remember, tangent is y over x. But what did we just find out? The point that we are using is negative negative. And isn't it true that if you divide a negative by a negative, it comes out to be positive? So that when they write 3/5, and I'm talking about this kind of point, really I'm talking about negative 3 over negative 5. So the value here of y is negative 3, and the value of x is negative 5. Now if I have y and I have x, I need to find r. R is the square root of x squared plus y squared. That's the square root of negative 5 squared plus negative 3 squared. That will give you the square root of 34. 34 does not break, so we'll just leave it as is. We need to find the cosine of theta, and we need to find the cosecant of theta. Now cosine is x over r. My x is negative 5. My r is square root of 34. You have to rationalize so that you'll get negative 5 square roots of 34 over 34. And I want to find cosecant of theta. Cosecant is r over y. So that's the square root of 34 over y is negative 3. Always bring your negatives to the top. So you get negative square root of 34 over 3.